If you ever, click the link and everything just loads instantly,
Mhm.
like magic. Or maybe you've hit that really frustrating 404 not found page. It feels like a broken link, sure. But it's actually, well, it's a little peek behind the digital curtain. There's this whole invisible language happening, hidden conversations, really, behind almost everything you do online. Okay, let's unpack this. So today, we're doing a deep dive into something called Application Programming Interfaces, APIs. Think of them as like the unsung heroes, the digital messengers making sure different software can actually talk to each other smoothly. And we've got this great source material as a kind of cheat sheet that lays out common API test cases and, crucially, those HTTP status codes. Our mission here is basically to give you a shortcut, to understand the details of why APIs work or sometimes why they don't, and what those cryptic numbers like 200 or 404 really mean.
What's fascinating here is how these signals, they seem small, right? But they're the absolute bedrock of reliable software. Every time you tap on your phone, buy something online, even just scrolling, it all depends on this intricate dance of API calls. And understanding these signals, the little differences between them, it really helps you make sense of the internet's underlying language. You're not just seeing an outcome, you're getting clues about why.
Right. So let's talk practicalities. How do we make these digital chats reliable? This cheat sheet really hammers home how vital thorough API testing is. It's not just, did I get a response? It's about getting that 200 OK and knowing it genuinely means success. Like the sheet points out you have to check the response format. Is it JSON? Is it XML? Is it structured correctly? And it also talks about validating the actual data in the response. What's a common slip up there, even if you get a 200?
Oh, yeah, that's where things get tricky. A 200 OK might look good, but maybe the data inside is messed up. Or, a really important field is just missing or wrong. I've seen teams chase bugs for days, and it boils down to maybe one wrong character in the JSON, even with a success code. So the cheat sheet reminds us, check the status code, but also check every expected field, make sure the data is right, and check the response time. Is it fast enough? It's about the whole picture, the integrity of that interaction.
Absolutely. Integrity, it's a good word for it.
Yeah.
And it's not only the response side, is it? The cheat sheet also gets into request itself. Sending the right parameters, using the correct method, GDT for fetching stuff, POST for sending new stuff, making sure the endpoint URL, the address, is spot on. Why is nailing the request so critical?
Well, using the right method, say POST versus GET, isn't just about making it work. It affects security, for one, and also something called the idempotency, basically. Can you safely repeat the action? And the cheat sheet points out a good API needs clear error messages, too. Like, what if the request is missing something important? Or you try to, delete something that isn't there? The API should tell you specifically what's wrong. That error handling detail, often overlooked, but so important for reliable systems.
Okay, let's circle back to those numbers. The HTTP status codes. We all know 404 not found. That feeling when you show up to the party and the house isn't there.
Right.
But this cheat sheet helps decode some of the others too. So what does this all mean when we're trying to read these digital signals? Okay, you've got the 200s for success. 200, okay, 201 created when something new is made. Simple enough. Then the 300s for redirection, like 301 move permanently. Your browser handles that usually. But the cheat sheet really highlights the differences in the 400s, the client errors. 404 not found is common, but what about 401 unauthorized? That means you could get in, probably, if you had the right password or key, whereas 403 forbidden means, nope, you're just blocked. Access denied. Full stop. That little difference. Super useful for developers trying to figure out what went wrong. It's that kind of nugget the cheat sheet offers. And then the 500s, like 500 internal server error. That tells you the problems on their end, the server side.
Yeah, and if we connect this to the bigger picture, understanding these codes means you're not just, passively clicking. You see a 404, you know the resource isn't there. A 401 versus a 403. Now you have a hint about why access was denied. Is it credentials or just permissions? You had a 500, okay, it's probably not your Wi-Fi. The website itself has a problem. That's empowering, right? This raises an important question. How often do you unconsciously rely on these hidden digital conversations every single day? And how much clearer are they now?
Right. Hopefully this deep dive gives you, a new appreciation for all that invisible work happening constantly, the complex infrastructure that just makes our digital lives work most of the time. So the next time you click a link, maybe refresh a page, you might notice those little signals a bit more, armed with a bit more knowledge about what's really going on behind the screen.